Hi, my name is David, and I'm joined here today by Krisha and Nathan, and we will be presenting our physical element of our project here. Similar to the simulation, this is a teaching tool for transistors. It allows students to very quickly and easily see the operating characteristics of transistors using lights and some displays here. I'm going to walk through the basic layout and the components of the circuit, as well as the flow. And Krisha will be handling the operational demonstration showing how to actually use the circuit. So starting out here, we have the main component, the Arduino, and that provides all the computational power for the circuit. We've uploaded some codes here that will record measured voltages directly from each of the transistors, and it will use those to calculate currents. It also drives our region indicator light here, if you can see that, and as well as driving our display. We have a potentiometer here that controls our input voltage, two single pole double throw switches. This one controls which branch of the circuit is being supplied, and this switch controls the displayed circuit. Up here we have our transistors. This left branch is the NPN transistor. This one is the PNP. And we have all of our emitter, base, collector resistors up there. And then we also have a load for each of these, which is just in the form of an LED. And that allows you to very quickly see the voltage and current characteristics as the voltage changes, and that's indicated by the light getting brighter or dimmer. This module up here is the I2C module, and it simplifies the wiring by only needing 4 wires here: a voltage, ground, serial data, as well as a serial clock, and those 4 wires replace all 16 of these pins. So it greatly simplifies the circuit. So now I'm going to go through a kind of the flow of the circuit, tracing it through. Along this row of the Arduino, we have all of our analog inputs and outputs, as well as our 5-volt and our ground pins. This other side has all of our digital inputs and outputs. So starting here, we pick up 5 volts and ground, and we supply that to our power rail. It runs all the way along here. We also jump that up to the top side so we can pick up power and ground from any location. We use capacitors here on our power rail for decoupling purposes to help filter any noise and just smooth any transients in our signals. Moving along here, we pick up power and ground for our potentiometer, and that is output through here. It's output into 2 places. One of them is here, and it goes through this resistor and back into an analog input here, and that allows us to directly measure our input voltage. The other location is this switch here. It feeds one pole of the switch, and depending on the position of the switch, it will feed either the NPN branch or the PNP branch. Moving down here, we have power and ground supplying this switch, and depending on the position, it will send a very clean high or low signal to our digital input, and that will be responsible for changing the displayed region there. This LED is responsible for indicating the region from cutoff to active to saturation. It will change colors, and that's controlled by an output from one of these 3 digital pins here, flows through a resistor and changes the color of our light there. Each of these blue wires is a voltage probe, and it is directly measuring one of the voltages on the different nodes of the circuit, and those go back through resistors and into analog pins of the Arduino, where they can be directly displayed as well as used in calculations to determine currents. At each of these analog nodes, we also have a decoupling capacitor that bridges from the analog node to ground, and again, it's there to smooth the signal and eliminate any unwanted noise there. At each transistor, we have a load light that again will just change brightness depending on where the transistor is operating. And that should be all of the layout there. So I'm going to hand it off to Krisha, and she'll do the operation walkthrough.
Hi, I'm Krisha. I'm going to be explaining all the ways you can use this transistor trainer and all the little details, along with some of the functions that can be found when using this transistor trainer to demonstrate. So to start, we're going to press this button on the Arduino Nano to reset it. So it'll come back up, and it should say transistor trainer at the very beginning. So starting at 0 volts in, I am in an NPN transistor since both of my switches are to the left. And one thing to make sure when you are using this transistor trainer is the switches must be going the same direction, or the display and the transistor used will be opposite. So since we both are on our left, we're in our NPN, and this can be seen here. So to start, the white light indicates we're in cutoff, as you can see there, and it is also indicated right there. So as we increase the potentiometer, we can see that the light has now turned green, indicating we are in our active region. An active region typically happens at 0.7 volts for our VBE. So now watch as I increase this very slowly. The load LED comes on and gets brighter and brighter as the voltage increases. Again, this whole time I'm still in active, and I'm going to keep increasing it until here I am in saturation. At saturation typically happens at 0.2 to 0.3 volts for our VCE. And as you can see, I'm going to keep increasing our VN, and our LED brightness, our load LED brightness, should not change. So now I'm going to show the same process for our PNP transistor. Again, being sure to have both of them going the same direction. So here we are. Now we're in active. Our light increases until we hit saturation, and the light no longer increases from there. So on our display, we have on our right side 4 voltage values, and on our left side we have 3 current values. So the voltage values are being recorded like they are being physically recorded from the circuit and observed at any given moment, while the current is being calculated by the Arduino Nano. And that concludes the physical presentation of the transistor trainer. Thank you for watching.